Good afternoon, or good morning, good evening, wherever you're joining us from today, and welcome to another PV Magazine webinar. This is Mark Hutchins, editor here at PV Magazine, broadcasting on another sunny afternoon here in Berlin. I hope, of course, everyone is managing to stay healthy and comfortable and coping okay with the various lockdown conditions in place around the world currently. And thank you for choosing to spend some of your time with us, for joining in with our webinar today. It is great to have so many of you joining us this afternoon. I will just note, though, that we are hearing that webinar platforms are really being pushed to their limit with currently very high levels of internet traffic. So I will apologize in advance if anyone experiences issues with connection or poor sound quality today. We will have a recording of the webinar along with all of the slides up on our website not long after we finish the live broadcast today. So not to worry if you miss something, you can just head over to pv-magazine.com/webinars and you'll find the recording or the slides there. And today we are once again delving into the topic of module technology, the question of larger wafers, bifacial and other new innovations, and the all-important factor of how these affect production costs for a module manufacturer, and ultimately further down the line, the levelized cost of electricity, or LCOE, that can be achieved. And of course the strategies in terms of trackers and system layout, particularly, that can help keep this LCOE as low as possible. We will be hearing first from Mr. Terry Jin. Terry is the Technical Director at Seraphim Solar, and he will take us through some of the features of Seraphim's latest module, which is a bifacial module incorporating wafers at 166 millimeters in a half-cut cell format. And that module achieves a maximum power output of 445 watts. And while we're on the subject of modules, I think this is a great time to bring in our poll question for today for the audience. So the question is, what is the most important factor for you when considering which module to purchase? And the options you have there are efficiency or power rating, the cost per watt, the durability, the long-term performance, or bifaciality. Please, I see, thanks Frederica for setting the poll question up. Please, I'll give you a couple of seconds to get some answers in.
Mark, this is Frederica. There was a slight technical problem. The poll has unfortunately closed already.
Oh. So, I see. Yeah, we have 0% for everything. Okay, I guess we have to leave that for now. But after we hear from Terry Jin this afternoon, we'll have a second presentation from Mr. Pedro Magalhães. My apologies, Pedro, for butchering pronunciation of your name there. Pedro is the Global Director of Engineering and Research and Development at tracker manufacturer Arctech Solar. And he will be taking us through some of the key considerations when it comes to combining new module technologies, such as many of those exhibited in this new module from Seraphim with Arctech's trackers. And we'll hear about some of the optimizations that are possible ultimately to get more energy yield for a similar investment cost. And I think particularly for bifacial, there are some very interesting findings coming out recently regarding maximizing that energy yield figure. Would you agree, Pedro, that there's still plenty more to learn about tracker and system optimizations with bifacial?
Sure. So, in a PV asset, we're not looking at a single component. We're looking at the best combination, the best tandem between all components. And, there's a lot to be said and done about finding the perfect marriage between the module technology and the tracker to use.
Absolutely. Thanks a lot. And we'll have plenty more from Pedro later on. So please do get in touch with all of your questions for both of our speakers today. As always, we have the live chat feature up and running for the webinar, and you can send in your questions there. I will be feeding questions into the discussion as we go today, so please don't be shy, and we will do our best to get through as many of the audience questions as we can in our 1 hour slot this afternoon. One question I will quickly answer now is that yes, the slides from today's presentations will be available afterwards. These will be emailed out to all those who registered, and you can also listen back to the webinar again on our website at pv-magazine.com/webinars. Okay, I will now hand over. Oh, do we have the question working?
Yes, we do.
Okay, shall we quickly run that again? Okay, I see answers quickly coming in. And well, there we go with 1 minute for the questions. Actually, not a bit more of a split than I was expecting there. A lot of people going for just the efficiency or power rating by itself without considering the cost, but cost per watt with 44%, still the biggest deciding factor there. And with that, I will hand over to Mr. Terry Jin of Seraphim Solar. Terry, please tell us a bit more about Seraphim's newest module.
Yes, thanks, Mark, for the introduction. And hello, good day, everyone. I wish you all and your family are healthy and safe in these trying times. I'm very glad to have this webinar today. Like Mark introduced, I'm Terry Jin, Technical Director of Seraphim Solar. Today, I will be sharing our opinions on the trends in solar module industry and possible ways to find a new balance between cost and efficiency for a lower LCOE of your PV project. The reason why we choose this topic today is that despite of all the different kinds of wafer and cell sizes, module, packaging technologies, we all have to solve the core and sole question: how to make the module of your solar project, how to make the most of your money. So we have done a lot of paperwork and experiments, talk with our clients, scholars, EPC, suppliers, financing agencies, and here we are going to share all of our findings with you now, today. And today we have three topics. One is about Seraphim. I will make a very simple introduce about Seraphim. And the two part will talk about the mainstream of the high efficiency technology. And the third part, I will share our new 160mm half-cut modules information with you all. Okay, let's start our topic today. Yeah. First, please allow me to give a brief introduction about our company, Seraphim Solar. Seraphim Solar was founded and entered solar business in the year of 2011. So far, we have 5 gigawatt global capacity, with 3 major manufacturing bases in China, 1 in South Africa and 1 in Japan. All of them are equipped with high automatic production lines, and all the products have to gone through 100% 3-time yield test before they go packing up. Since 2018, we have earned the honor of top performer by DNVGL, and also we are a BNEF listed Tier 1 module manufacturer. With a world-class R&D center located in our headquarters in Changzhou, China, and over 20 located offices around the globe, we could provide instantly the professional service to all of our clients. So far, more than 8 gigawatt Seraphim module has been installed in over 40 countries. And in Europe, now we have located sales team in Italy and Spain. If you have any inquiry about our product, you can send an email to us and leave the message to our LinkedIn. Yeah, very simple introduction about Seraphim. Well, let's move on the part 2, the mainstream high efficiency technology. As you may say, solar industry developed very fast in the past few years, not only in the cell level, but also the module phase. Now we have a cell applying PERC, TOPCon, HJT, and other technology. Then we have half card, triple card cells. But one thing is common. The wafer and cell size is getting larger and larger. I'm sure that you are all aware of the trend in making larger and larger wafers. So in the page 7, yeah, you will see in the left bottom, you can see the cell size development from the M2 of 156.75 millimeters to G1 of 158.75 millimeters cell, even to the 166 millimeter M6 cells. Furthermore, the number of the bus bar has always increased. The right table is the latest price list published by PVInfoLink this April. As you can see, the cost per watt of M6 wafers, cells, and modules are the lowest. You can slip the second column, which talked multi-polysilicon, and compare with the 4 column in the right. After that, we can easily join the following 3 conclusions. First, the surface area of M6 cell has been increased by 20% than M2, which have reduced module production cost by 0.003 USD per watt. And the second, compared to G1, M6 cell production cost is reduced by 0.065 US dollar per watt. And the third, with 166 millimeter large silicon wafers, 17 cell module gains additional 50 watt output. In addition, the 9BB can bring 5 to 10 power increase. Yeah, this is a large wafer advantage. And another technology can improve our power generation is MBB. And why MBB technology can increase the module power? First of all, the picture shows to us, the 9BB cell has a thinner bus bar than 5BB or 6BB. So we mark the bus bar wise with A for 9BB and the 5BB wise with B. So from the picture, you can easily to find the 9BB cell bus bar is thinner than the 5BB or 6BB. And for this, when we soldering the ribbon to the solar cell, the thinner bus bar can use a thinner ribbon, and the ribbon will shadow less cell area. This is from the module packing part. We can increase the efficiency. And the last bus bar can increase the working area of cell. So totally for these two parts, that there has an optical advantage to increase the module efficiency by MBB than the 5BB modules. And for the bottom picture, we can see because of the 9BB bus bar is thinner than the 5BB, we can use thinner ribbon. So the MBB ribbon is different with 5BB or 6BB traditional ribbon. For the 9BB ribbon, it has a curved surface. Yes, the showed on the bottom. So we confirmed that the ribbon used for 9BB has a curved surface, different with 5BB flat surface. Curved surface can get more reflected light to the cell working area. That can reduce the module CTM power loss. Yes, so that's why MBB module power can higher 5 to 10 watt than 5BB modules. Yeah, this is optical advantage of the MBB. Third, the MBB technology has lower resistance loss caused by the less distance between the bus bar to bus bar. Yes, this showed on the left picture, and this can help the bus bar to collect the current fastly. And when you can see the shadow area. That means when the crack happens, the 9BB has a smaller dead area than the 5BB. So all of this is the MBB advantage. So and the MBB technology has become more and more popular, and most of module factory had switched to our traditional 5BB to MBB, 9BB or 20 or 12BB to increase the module efficiency. And the right side, right part, let's talk about the half part. As we know, solar cell current has a linear relation with the cell area. So we cut the full cell to the half. The current will become the half of the full cell. So, you know, for the power loss, we can calculate the power loss by this. The power loss equals the square of current multiplied by resistance. The half cut cell current owning half of the full cell. So the total power loss for the half cell module is 1/4 of the full cell module. Lower current, lower power loss. Okay. Now let's take the third part. Our newly released 166mm half-cut module as an example. Seraphim 166mm half-cut module integrate 166mm silicon wafers with multi-busbar and half-cut cell technology, which can deliver power of 445 watt or higher. And the maximum module efficiency is up to 20%, satisfying criteria for some higher requirement projects. And the bifacial 166mm half-cut module have the bifaciality rate up to 7%. We expect the new module to see a good start in 2020 and achieve implemented growth in the future. Now let me to make more information about our new modules. Mark, can you help me to confirm the page? Go to the page 12.
I'm seeing slide 13 at the moment, Terry. Ultra high output. Oh, now you're back to 12.
Okay, now it's 12. Sorry about that.
12,
we have some delay of this. I will try to match the presentation. Okay, now is the 12, page 12. Okay. Yeah, here are the parameters about a monofacial and bifacial 166mm half-cut module. All this can show our dimensions, the powers. Oh. Excuse me, Mark. Now is in the 12.
Now I see 13, Terry.
Oh, sorry, there has some delay for that.
Sorry.
I'm still talk about the 12. Yeah, page 12.
There we go. Now I see 12.
Okay. So these are some parameters of our new modules. You can check. You can see the dimension, the weight, and the efficiencies. The module weight is around 25 kilogram, and the module efficiency can reach to up to 20%. Yes. So we can offer both monofacial and bifacial modules. And about the bifacial modules, we can both produce with frame or without frame. So I think later for Arctech, they have more solution to for the bifacial module installation. So if you have any you want more information about our new product, you can visit Seraphim website and to download our datasheet or contact us to get the datasheet. Okay, in page 13, here is a vivid graph describing the ultra high output we can achieve with 166mm MBB half-cut cell. The output of the standing module use M2 model cell is about 385 watt. If we replace M2 cell with G1 cell, there will be 5.2% more power generated, making it output to 405 watt. Let's have another try with 160mm MBB cell. The power now reached to 445 watt, which is 9.9% higher than G1 modules, and totally has 50.6% higher than M2 modules. So the 166 module has bring the ultra higher output than the M2. Okay, for the page 14. On this page, I would like to talk with you more about bifacial cell and the ultra power gain they would bring. As you can see from the graph, the left is the structure of PERC monofacial cell, and the right one is a PERC bifacial cell. Their structures looks very similar. We only need a few more processes to convert a monofacial cell into bifacial cell. In this case, bifacial modules are capable of converting energy from indicate light and diffused light on the front side, while converting energy from reflected light and slatted light on the rear side. With PERC technology, it become more and more widely applied and affordable. The selling price difference between monofacial and bifacial modules is getting smaller and smaller. So in this new series of 166mm half-cell bifacial module, we have managed to improve the module bifacility rate up to 70 plus minus 5%. Therefore, it would bring 5% to 13% more power generation. The table below shows that if we install bifacial module on different places, we can get different power generation gain. And it will be 5% to 13%. And next page, I want to share with you all is for the example for 1 megawatt project. And the table showed a cost breakdown of 1 megawatt project. All this cost is based on Chinese domestic project, okay? And the table shows to building a 1 megawatt project, we need a grounding project. We need around 10,000 square meters land if we use the 375 watt modules. But we only use 8,000 square meter land for the 435 watt modules. That means this can reduce the land rent cost. And I highlighted with the green color with the first line. And also, they can reduce If we use less module for installing, it will be less tracker need, less DC cable, and less manpower. So totally for this, we can draw in a conclusion that the new module with 166 half-cell module could save around 15% BOS cost. And next, we collect some published data from some third-party tests in different areas, like in China, India, and Middle East. And the fourth one showed the power generations between half-cell modules and bifacial half-cell modules under different on the different place. You can see the bifacial at least have 10% or 10% more power generation, and with the different conditions like the sun, the white plants, that will get more powers. And from the others, like the India and the Middle East, that shows the bifacial module. We under different months, like August or even December, the lowest in radiation in the year, the bifacial module still has more powers than the monofacial. So there, that we can have the believe that for the utilities project, the bifacial modules will be the future. That will be more and more popular, and the bifacial module could generate more powers and improve the project return rate. And the last one I want to say, with years experience in solar produce manufacturing, Seraphim has a very good experience for the smart manufacture. That we can not only increase our manufacturing efficiency and have very stable qualities, that for the bifacial modules, we can offer 15 years product warranties and 13 years linear warranty for bifacial modules, and which are 5 years longer than industry mainstream. And also we have the very good reliability, like Class A fire resistant and very good 5,400 Pascal mechanical load. Yeah. Okay, so this is all I want to share you today, and thank you for your listening. And here is our contact information. If any comments, you can contact me or my team directly. Mark, that's all for me.
Okay, thank you very much, Terry, for a very informative look at Seraphim's new module there. And thanks to everyone listening for your questions this afternoon. Plenty of questions coming in. First of all, Terry, could you just confirm this is a glass module? Is that correct?
Yeah, we can offer the two types. One is traditional modules with a glass backsheet, and also we can produce the glass module. Yeah, both.
Okay. And have you considered bifacial with a transparent backsheet as well?
Yes, we still have this option, but still for our R&D team. Yeah, because we our lab is testing the transparent backsheet reliability. And I think in the middle of this year, we will have more data to support us that we will decide if we will provide the transparent backsheet bifacial modules or not.
Okay, sure. And when it comes to making a module bifacial, are there many more additional processes that need to be added there? But is there more cost in the module production that's added just to make the module bifacial?
Like I mentioned in my presentation, the PERC technology is developed very fast. For the bifacial PERC, cost is very close to the monofacial cell cost. So it's not too different from module factory to use the monofacial or bifacial cell to make the modules. So I think bifacial module will be more and more popular in the future for utilities project.
Okay, sure, that makes sense. Okay, thanks again, Terry, for your presentation and for answering those questions. But time is moving on, so I think we had better push on with our next presentation from Pedro. Pedro, please, if you're ready, please go ahead.
Right. Thank you, Mark. Thank you, Terry and Seraphim, for inviting myself and Arctech to your webinar. And greetings to all our attendees. Thank you for being there, listening to us. Many of you on a rather challenging time zone. So we just heard from Seraphim's and their value proposition, and I'll talk about how Arctech Solar pairs our own technology with the bifacial technology and value proposition on the module side. I am Pedro Magalhães, Director of Global Engineering at Arctech, and I won't spend too much time in presentations here, but Arctech has been part of the Big Five Tracker Club for the past 4 years, and today I'm presenting the novelties we are bringing to the market this year of 2020 to lower LCOE and enabling even more expansion of PV as a global electricity source. So I'll move on to the next slide here. Just very, very quickly, there's one thing that is very unique to Arctech Solar, which is, like I said, among that Big Five Tracker Club, it's probably the only one with massive deployments on both common tracker architectures. 1P, which we call SKYLINE, and 2P, which we call SkySmart. So we have deployed about 2 gigawatts of SkySmart and 3 gigawatts of SKYLINE, and that means that the market is telling us there is enough demand for both different architectures. It is also telling us that this knowledge between the differences, the advantages and the disadvantages of both technologies is very, very important to anticipate what the market will ask for in the future. So we at Arctech have that knowledge because, like I said, we've been deploying these both architectures for 3 years now. Just to put everybody in context here, our 1P tracker is our simplest tracker. The least challenging to design in terms of wind loading, and hence our lower product cost tracker. It's been proven, or it's been the chosen one when we have flat land and in projects with conventional PV panels. On the other hand, sorry, jumped too fast. Our 2P tracker here, which we call SkySmart, has been a better fit in challenging topographies because it's shorter and mainly in bifacial projects. So speaking of bifacial, both our internal research and independent marketing out there tell us that this technology will be dominant. It was very, very important in 2020 already, with shy of 30 gigawatt deployments, and so we need to be in tune. That everybody else that participates in the PV plant needs to be in tune with these industry trends. So we from Arctech are evolving as well, from the tracker perspective to enable lower LCOE. So after careful research, we look at our both trackers according to our experience, and we make a few, a comparison about the variables that are influenced more by bifaciality and yield caused by bifaciality. And I just put two very evident things here. The first one is that 2P trackers sit higher up, which means that they collect more reflective energy. And on the other hand, if I have a 2P construction, I have the choice of avoiding shading on the back surface by spacing those panels away from the torque tube a little bit more. Okay, so these two things seem to indicate that 2P is best proposition for bifacial to begin with. But as we all know, 2P has been historically a little bit more challenging tracker to design due to the largest cord, to the largest dimension, of the tracker. So, I'd like to introduce you SkySmart 2, which we believe is the 2P tracker that will solve these challenges. It will be as stable, if not more, as our 1P tracker, and it will finally be able to be produced at the same price point. So this tracker really quickly is a 4-string tracker, mounts a maximum of 120 modules, and that allows for a nice round number of 50 kilowatt capacity, and it keeps the main features of our current product lines. It's still an independent row. It's powered directly from the string. It does not rely on miles and miles of AC cabling. It does not rely on a single panel 100%. It does not rely on cycling a battery every day from 0 to 100. It gets powered directly from the string. It keeps the same slope tolerance, and it finally gets rid of the 3-string, typical architectures that we've been using in the industry. This will make electrical plant design much easier and more cost effective. But this is just what we used to have. This was not, or these items were not the main design drivers. The main design drivers were first of all to be the most adequate for bifacial panels, and after understanding that 2P is the best architecture for that, the challenge we had to overcome was, okay, we got to make it as stable as 1P, like I was saying, without increasing the price tag. So our 2P SkySmart, the previous one with the traditional slew drive in the center, was already as stable as 1P, but it required higher steel content and several dampers. We had up to 6 dampers on exterior roads and 4 dampers in interior roads, right? It also presented like a mixed stow strategy of 30 degrees and 15 degrees. So all these features combined, drove the price up in comparison to the 1P architecture. We were forced to doing that if we wanted to keep the same, an acceptable stability and performance. With SkySmart 2, we overcome that challenge. We engineered an advanced multi-point drive, as you can see here in the screen, which increases stiffness throughout the tracker in a way that stability against wind dynamic effects increases by about 3 times. So, this is a solution for the most pressing challenge in terms of 2P architecture. It's like wind stability. And the key to reach an economical 2P tracker was this increase in stiffness, which can finally, we hope that this 2P architecture can finally become the standard of the industry together with bifacial modules. That's our vision. So a little bit more detail here, which I forgot to mention. Apart from that wind stability, we are pairing this SkySmart 2 with our new artificial intelligence controller, which I'll glance over a little bit. This artificial intelligence controller is already available and being deployed, but it really shines when you have bifacial projects. So it basically includes 2 features. The first one is this, what we call topo backtracking, which actively prevents shading by correcting the shadow profile with regards to the topography. So the result of this is maximizing light collection, and it results, depending on the project, on 2 to 4% more electricity generation. The second feature of our artificial intelligence is active monitoring of cloud shading. So when we have clouds, mainly partial clouds, diffuse radiation increases. So the maximum power point is most likely not to be when the trackers are facing the sun directly. So tracker tilts adjust to maximize energy. And you'll notice that I say maximizing energy all the time, not collection, because the whole strategy is to measure energy, the useful energy that we can use. So the way we do this is, we pick specific trackers throughout the field, and those trackers scan around their theoretical tilt, and every time they find a point where we can have more power, they change the tracking parameters. So they communicate that to a central communication box, and that central communication box then broadcasts the new parameters, the new tracking parameters to everybody else. So as a group, we can generate more electricity. So when you put all of these things together, topo backtracking and cloud profile, and using this communication strategy that I was just explaining, we can have 2.5 to 6% more electricity in total. Okay, but now if we want to go back to the mechanical side, it's great to have like 10% more, like Terry was saying, 10% more energy because of bifaciality, and 5% more because of intelligent algorithms. Well, all of that is nice and very important, but it doesn't matter if the tracker flies away. And I am always very blunt in this question, because we've been observing and witnessing lots of those unfortunate incidents, and I still say that the single most relevant topic for the tracker industry today, in light of those countless failures, is tracker stability. Again, tracker stability. Historically, 2P trackers have been much more sensitive to that matter. Here we are at Arctech proposing a 2P tracker as the future of the tracker industry. It looks like a paradox. Well, it's not a paradox, because through vast research, we gathered the knowledge, and we were able to really understand the knobs that we had to move to make a 2P stable tracker. And I don't have too much time. I think we have like 7 minutes left, but I'll just glance over that really quick. So the industry is used to these many wind tunnel tests, a static test and dynamic test, and then they go and they do stress calculations and they size components. When everything is said and done, they go and they try to check for stability. Most of the trackers out there just like put one tracker and do these CFD analysis, and they stop there. Other trackers just go and they walk the extra mile and they put a bunch of trackers and they do a true AEROELASTIC analysis with many trackers. So we at Arctech went beyond. We understand how sensitive this thing is. And with our partner CPP in Colorado, we created this, what we call the AERO+. So when I typically explain this to people, I show this in levels. I think it's easier. So you absolutely must do level 1. Most of the people have done level 2. Some people have done level 3 and stopped there. A few people have done level 4. So we are reshaping the way we calculate trackers by creating level 5, which we call AERO+. So what is AERO+? Well, AERO+ is truly the first way of connecting wind tunnel test that is only used for stress calculations done in rigid trackers with flexible trackers or wind tunnel test done in flexible models that were only used for deflection calculations. So with AERO+, we can run a wind tunnel test in the deflective tracker in real flexible models, as you can see here. See, this is me hanging or holding a tracker, and I'm just putting my finger on the tracker. You can see how flexible that thing is. So that tracker mimics exactly the real trackers in the field in terms of stiffness, natural frequency, and damping ratio. So the minute you blow wind, it starts deflecting exactly like the real tracker in the field. But the extra mile that we have walked is we are not only looking at stability. While the tracker is deflection, we are measuring pressures, moments, and forces at the same time. So the best way is actually to watch and see what's going on. See those trackers oscillating over there? See that there are these posts over here with these devices. These are potentiometers that are measuring moments real time. We have other potentiometers right there. I don't know if you can see right here. I'm trying to point with my mouse. But the point I want to make is that the industry has been doing coefficients on trackers that are nothing like reality, and then checking for stability on the results. We are getting coefficients from the real deflected shape. And this is game changer. This is what the industry needs to evolve to, not only Arctech, everybody else in the tracker world. So moving on, to finish really quick, these are typical curves of stability. So you can see that with the typical tracker that we see out there in the industry with a single screw drive, very flexible structures, the worst possible stow tilt is 0 degrees. I've been preaching this for such a long time. Every time I talk with like APCs and owners and insurance companies, banks, I say, run away from a tracker that is that flexible stow that's 0 degrees. You can see, empirical test results right here. 0 degrees just does not work, guys. Okay? So if you want something safe, you need to tilt the trackers, at a steeper tilt. Except when you get SkySmart 2. And this is, a realization that we had as the result of stiffening the tracker so much. If you stiffen the tracker, you invert that peak in the curve. So all of a sudden, we are pushing the curve up, and 0 degrees is not only acceptable, but the best tilt to stow your tracker at. So this goes against, the current knowledge that we currently have in the industry, because all trackers are very flexible. Well, think about a tracker that is very rigid. This is the result that you'll see. And this is the key that enables us to design SkySmart 2, stow it at 0 degrees, and make it on par with 1P in terms of stability and cost. So just to finalize really quick, 3 takeaways for you. SkySmart 2 with bifacial, will be the highest value proposition in this industry because we will have the benefits of 1P and 2P combined. And we will boost that with our artificial intelligence algorithms, and this will increase generation. After you make sure that your tracker is safe, secure, and reliable, you go to your optimizations. So fundamentals first, tracker stable, lower cost, reliable. Optimizations next, artificial intelligence, boosting energy generation. And with all of these programs, we want to help reshape this industry and actually, drive the tracker industry to start doing things like this as well. I think that's all I have today. If there are any questions, I'm happy to take them, Mark.
Okay, great. Thank you very much, Pedro. Another very informative presentation there. And indeed, there are plenty of questions coming in. So I will start just looking at your wind demonstration here. There's a few people wanting to know what actually happens to the modules when the tracker is made more flexible in this way.
Right. So the main flexible or the most flexible components in the standard trackers we've been having so far is what we all call the torque tube, right? So the modules are mounted directly on top of the torque tube, and as the torque tube twists, the modules will go with that twist. Now, the modules or the strings of modules are not continuous surface. They are discrete modules. Right? So you are not to expect to see the same twists on a module as you are expected to see on a torque tube. So what we do with our module partners is we break that twist into chunks of 1 meter in our case, which is the width of the module. And then we need to make sure that the torque tube is stiff enough not to go beyond the torsional capability of those panels. Oftentimes that's set about 1 degree. So we have means to control the deflection of the torque tube, not to exceed the discrete deflection of every module onto it.
Okay, sure. I think that's very clear. We also have plenty of interest in the control system that you mentioned. Is this manufactured in-house by Arctech?
100% in-house. So we have designed, so it's fully designed and it's a manufacture. It's like a Swiss watch. Everything done in-house. Obviously we buy standard components, standard electronic components, but the full design and manufacturing is done at Arctech specific tracker factory.
Okay, certainly. And how actually within a system, how does the control unit work? Is there one for each tracker or each row, or how is that?
Right. So for us, 1 row and 1 tracker is the same thing, and we do have a set of mechanisms plus 1 control box per individual tracker or per individual row. Those individual controllers are connected to a centralized communication box that's, broadcasts some information, like I was explaining the artificial intelligence routine, and also, sends information of a group of trackers directly to SCADA. But the direct answer to your question is each single tracker has a separate control box, yes.
Okay, certainly. Okay, folks, we are coming up to the end of our 1 hour slot this afternoon. I will squeeze in one more question for you, Pedro. Does it make sense with a 2P tracker? Does it make sense to split the strings on the top and bottom rows?
Right. So well, no matter what we do, we will have 2 strings on the northern side and 2 strings on the southern side, right? So I think that your question is, should we arrange those strings, one full on top and the other one full in the bottom, or should we have the arrangement that I showed with my collars? So, ultimately that will be up to the plant designer, the electrical designer. Our experience has been that if you, do not put 1 string on top and 1 stick in the bottom, you actually even out the current and the outcome. Due to when you have shading, when you are doing the backtracking, if you tend to shade the bottom row the most. So if you shade the bottom part of the tracker, you would shade both strings equally. While if you split the string, so only 1 string is in the bottom, that string would not be yielding anything, and the other one would be yielding a lot. So we believe that it probably makes more sense to actually even out outcome or energy production.
Okay, certainly. Okay, thanks very much, Pedro, and thanks to Terry as well, and the guys at Seraphim for 2 great presentations this afternoon. I think we'll have to leave it there. So please, thanks also to everyone listening, and yeah, plenty more webinars coming up. Please keep an eye out for announcements from PV Magazine, and yeah, have a great evening.
Thank you, Mark.
Thank you.
You take care.
Thank you.
Bye, Terry.
Nice day, yeah. Bye.